it seemed a little odd because if we started with, what did we, I have 50 here, but if I put 100 in instead, then we have 200, then 400, and then 800. I think we even started with 200. Wasn't that what you recommended the other day? Yeah, and the numbers just get out of control. So that by the time we get to 1995, we get this ridiculously huge number that's hard to name, right? Some other things I didn't talk about the other day with this is, let's suppose that we actually got a hard figure, and let's say there were only 17 children gunned down in 1950. We still haven't defined what gunned down means. Were they killed, just shot and wounded? So that's a whole other issue. But let's say we did define it and we called it 17. It's going to double, it's going to be 34, it's going to double, it's going to be 68. Then we're going to get this ginormous number down here. So let's take a look at this ginormous number here. So copy that sucker, notebook. Let's make the font bigger somehow. Yeah, there you go. Big enough. So let's try and identify what number this is by just throwing some commas in there. So we've got there, 3 there, 3, 1, 2, 3. Okay, so let's see, what do we have here? We've got our ones over here, right? And then we've got our thousands, millions, billions, and trillions. All right, so chances are we saw this billboard, they're talking about the United States. Anybody know roughly how many people are in the United States right now? Like 400 million, roughly. So we're exceeding the population of the United States for sure. Anybody know about what the world population is?
8 billion.
I don't think we're at 8 billion yet. I think we're still in the 7s. So we're approaching the population of the world here. Okay, so that's a problem. So this is unrealistic. So something's wrong with that statement. Other thing to consider is this is a pretty detailed number, right? All the way down, 598 trillion, 134 billion, 325 million, 510,000, 144. Yeah. That's a pretty precise number, okay? From an estimate in 1950. So my point on that is some of these digits are not significant because we're estimating. Do you ever remember in a science class, the science teacher talking about significant digits? Yeah, so significant digits is kind of related to rounding. It's based on where you start. Where did we start? Well, if we look back at the spreadsheet I put up here, we started with 17, which is how many digits? 2. So we only have 2 significant digits. So that means all of those other digits in that number, even if the doubled every year starting at 17 is right, all those other numbers are irrelevant. So we started at 17, which has 2 significant digits. So that means if this number were okay, then only those 2 digits would count. Okay? And usually what you do there is then you look at the 3rd digit and you round to over there. So what we would say is a more accurate number based on where we started would be that 8 rounds that 9 up to basically a 10, which makes that 5, 6. So basically we're going to say it's 600 trillion. Enough. Trillion, billion, million, thousand, hundred. Okay. Often when a calculator gets a big number like that, it's going to put it in scientific notation. So that's what we're going to start working on in section 2, scientific notation. Let's take a quick look at that. So scientific notation for that number would look like a 6.0, and that 0 is significant. Why? Because we're supposed to have two significant figures, right? So I need to write the 0 down in this case. And then it would be times 10 to some power.
Yeah.
And that power, basically, from where I'm putting the decimal point, which is I'm moving it right there, I just count the number of places I skipped. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So that would be the 14th power of 10 to move the decimal point that far over. Button, button, right button. So this would be the 14th power there. So that would be another way to state that number. I can also state it with all those zeros. I could say it's 600 trillion. So there's going to be a lot of ways we can state numbers. Usually in a math or science class, we would prefer this top way right here. But if this is like in some literature somewhere, maybe the news, it's going to be stated like this right here. And then we have to know what trillion means. So like trillion's more than a billion, right? I know that. Okay. So again, we came to the conclusion that this doubling every year is unreasonable. Just not possible. All right, let's take back the worksheet. We'll come back to some more scientific notation stuff. All right, so we went through page 1 yesterday. We started page 2 here. We started filling out this table. You guys need to finish that. And then we have the, does the number you predicted for the children shot in 1995 seem reasonable? What kind of information might you need to decide how? So you're just gonna have to decide on your answers there. Notice here it says, fill in the third column of the table, rounding the number to 1 or 2 significant figures. Okay. That's because, you know, a reasonable prediction here is not a lot of kids were killed by guns in the United States in 1950, so our number is probably going to be a 1 or 2 digit number.
Yeah.
Right.
And it could be like number that we started at double that number that we had in 1950. All of a sudden, and by the time it's now, that
number, yeah. So that, yeah. So it turns out that this quote came from a paper somebody wrote. Yeah. And in the paper the person wrote, that's what it was. Yeah. It was not that it doubled every year. Yeah. It between 1950 and 1995 it doubled once. Yeah, you nailed it. Let's see, here's that. Oh, that's not Tamara. Okay. So let's just play around with some other ideas. So everybody get a blank piece of paper in front of them. I just want to explore the idea of big numbers a little bit, because we started talking about page thousands, millions, billions, trillions. So I just want to get a sense of, you know, what's a million versus a billion versus a trillion versus 1,000. So I someday would like to be a millionaire and have lots of money, right? Gage, I'm sure you want to be rich too, right? So let's say you want to be I'm going to be a billion. What did I say, millionaire? You're going to be a billionaire. Okay. So someday in the future, I'm a millionaire and you're a billionaire. Question: will we hang out at the same golf club together and sip a drink of beer? Gage says no. Why? How come?
Yeah.
You make more.
Be at a nicer one.
You're going to be at a nicer one because you're a billionaire instead of a millionaire. So you think a billionaire is that much more of a big deal than a millionaire? Okay. Okay, so what if you were a trillionaire? Are you guys in the same club, or are you just way above him?
I own his club.
You own his club, okay, and he owns my club. Okay, so let's look at that on a piece of paper. So on your paper, you're going to draw from one side to the other a line. On the left side, I think that's the left side, you're going to put a 0. And on the right side, you're going to put 1 billion. I ran out of. Nice thing about digital paper is I can just move stuff over. All right, so there's my 1 billion, which for fun I could also write in scientific notation. What would it be? It would be 1 times 10 to the 9th power. Yeah, 1 times 10 to the 9th power. Yeah. So those are all the same way to state that number. All right. So that's where I sit on a number line. No, that's where gauge sits on the number line. I am a million. So where, if that's 0 and that's 1, would 1 million sit? Don't say anything. I just make your best guess. Make a mark on your number line as to where you think 1 million would be if 0's on the left and a billion's on the right. Just think about it for a minute, draw a line down. Don't worry about being right, just wing it. All right, anybody want to tell me where to put it?
Not in the middle.
Not in the middle. Okay, so let's just explore that for a minute. If we did put it in the middle, right, 1 million, if the distance from here to here is 1 million, then that would put 2 million right there, and 2 million definitely ain't a million, right? So that was a good suggestion. It should not go there. So let's do that mess. Okay, so it's not there. Okay, where should we put it? Rebecca, you want to tell me where?
Be like a little under half.
A little under half, like here-ish? Okay, so let's say that's 1 million. So then repeat that distance. That would be 2 million. Oh, shit, what do I do? Technical error. Whoa, I zoomed out. Okay, zoom back in. There we go. This has buttons on it. I should be more careful. So that would be 2 million, 3 million, 4 million, right? So that's not where it goes either, but good try.
Like an inch away from 0.
An inch away from 0. Okay, so on my board, an inch would be about right there.
Yeah.
Right? So
It's
1
not
million,
accurate either, but
2 million, 3 million, 4 million, 5 million, 6 million, 7 million, 8 million. That's not where it goes either, right?
no, I was just, yeah, you can't, I mean,
With these pixels, I can't put it there accurately.
yeah, exactly.
Yeah. So here's the question. A different question. Oh, apparently I messed up my board. Let me recenter it. I think my magnets on my strip here stopped working right. And this thing is sliding as I get excited. Stay still. Okay, so how many millions are in 1 million?
1,000.
Yeah, there's 1,000 of them, right? Because there's 3 zeros over. There are 1,000 million in a billion. Yeah. So when we talk about jumping from millions to billions, like we're debating bills in Congress and they talk about debt being in the billions or trillions, it's a huge jump from a billion to a trillion.
Like, where does that go?
Yeah, so 1 million is 1/10% of a billion. 1/10% of a billion. It's not even in the same ballpark. We do not go to the same club. Definitely not. You own my club, right? Yeah, you go visit me in my club, you're slumming it. Right, so huge difference. So we just got to get a handle on. We hear these numbers all the time, and I don't think we pay attention enough that there's a huge difference between a million and a billion and a trillion. Okay. And then the different ways we can talk about it. The idea of significant digits, the number of digits you start with controls the number of digits you should end with, because you really don't have that much accuracy once you do a calculation. Because you modify the result.
Richest person in the world has a net worth. That was the owner of Amazon. And there's people that should buy 20 grand a year.
Yeah, it's inconceivable, those two different figures, right?
Yeah.
20,000 versus 100 billion. Yeah, they are not, it's unbelievable. Distribution of wealth in the United States is crazy. Tamara, hello.
Hello.
Good to see you. So I've recorded some of the beginning so you can see what you missed later. I'll post that link for you. So we are talking about big numbers, scientific notation.
Okay.
All right, so let's see. So you got enough information to finish up lesson 1-1. So I'm going to leave that to you. Should the class continue, that will be turned in tomorrow. And again, for written work, you can take a picture of it or get it scanned, and then you can submit it here. Alternatively, you could choose the text entry and you can just type up your answers, right? So you could say number 1, blah, blah, blah. All right, right, and they even have a way if you want to put fancy math equations in there, you can do that. That's a whole other story. Otherwise, you could just take a picture of it and upload it, right? And you can do multiple submissions too. And I see every time you do a submission. One thing you can't do in Canvas is you can't edit a submission that you do. So for example, if you typed a bunch of stuff and then you realize, now I want to revise my answer on number 2. You can't go back, find it, change the answer. You just got to resubmit. So what you would do is if you submitted this one, 1, 2, 3, stuff, and submit, you would just do another submission and say, this is my new number 2, and then whatever you want to say here. And then I'll see that I'll see the second submission, and then I'll say, oh, there must be a first one. I can go back and see the first one. So I see whatever you put in there. Just for fun. Same thing with file uploads. You can do multiple file uploads in the same submission, or you could submit some files, come back, submit some more later. All right, let's leave student view. All right, let's take a peek at the online homework. Some good stuff we have there. We'll talk about the next lesson.
I'll remind my teammates again, put it in the group chat.
Okay.
I told them about it yesterday, but I mean, practice.
Yeah, people get busy, and once people have a schedule, it's hard to change.
Yeah, so I'll put it in the group chat again and see if it makes a difference. I hope so. It's the last end.
So some other notes on this class. When I put this class together, it's based on some work some other people did. They called the homework an out-of-class experience, which I first thought it was kind of cool, and I thought it was kind of weird. So I call it homework 1-1. They call it OCE for out-of-class experience. So if you see OCE somewhere, it just means homework. Okay. And then they have another one called PNLs. That's preparing for the next lesson. I just call it prep. Right. So sometimes I didn't edit out where they put OCE or PNL. I must have missed it. So usually what you'll see in the homework is the first or second question will be, what do you think the main idea in this lesson was? And again, you can try these repeatedly. So it says I'm on attempt 1 of 3. If you don't get it right by the 3rd try, then you get to try it again. Right. So maybe I think it's, you should not use estimation. Oh, that's not it. I think it's, you should not use estimation. I'm going to submit that again. Oh, it's still not it. Right. And then by the 3rd time, it'll give you the option of doing another problem. Why isn't it showing me that option? Selecting another question. I'm just batting 1,000 in the last 2 days. Attempts. Question 1. Oh, interesting. All right, let me fix that. 6. Go. Yeah, fixed. Now, if I get it wrong, try it one more time. Submit, submit, submit. There we go. Try a similar question. That's the way it's supposed to work. Okay, so you can try that. Yeah, so here is the original statement was the number of American children killed each year by guns has doubled since 1950. Right? It doesn't say doubled every year, it just says since 1950 it doubled, right? So if there were 17 then, there were 34 whenever this was printed, and it was around 1995. And here's a link to the original article, or a reference to the original article if you wanted to look it up. So suppose 100 children were killed by guns in 1950. If the original statement is true, that the number of American children killed each year by guns has doubled since 1950, what should the new number be? It should be 200. It's just doubling once, not every year. Yeah, so that's the way it should have read, but somebody reworded it a little bit. Maybe they didn't understand what that wording meant, right? And that was their language, but they misinterpreted it. Let's jump down here. So similar kind of problems. We got Marco is 35. He plans to retire at 65. His dream is to take a trip around the world after he retires. He figures he's going to need $100,000 to do it. His financial planner told him that his investments would likely double every 10 years. Figure out how much Marco would need to invest now to have enough for his trip when he retires, and complete the table below. So let's just pop this into a new window, give it a try together. So this is similar to the problem we just tried, but backwards. Okay, so every 10 years, his financial advisor says he can get his investment to double. So that means he's going to go 35 to 45, 45 to 55, 55 to 65. We want to end up with 100,000. So if it's doubling in one direction, what's happening in the other direction? Yeah, it's getting cut in half each time, right? So if we wanted 100,000 here, what would we want to have 10 years before? So we cut that in half, divide by 2, that should be what, 50,000? Next, I think 50. And then we cut that in half, 25,000. And then, yeah, it'd be 12.5 thousand or 12,500. Again, this is where a spreadsheet would be a great way to look at it, or a calculator is nice. So 12,500 would be that one right there. And so we just type those numbers in the blanks. Usually you can type commas, which I like to do so I can make sure I get the number right, zeros in there. Usually the system ignores commas.
Really?
Yeah. So let's check if this one does. Because otherwise it's really hard to get the number of zeros right.
Sometimes if you look at just the zeros, you just guess how many zeros are.
Yeah.
It's right.
So, oops, I got that wrong. It's 12.5. And I think I might have mentioned this yesterday, I can't remember. When in this system that we're using here, and most math classes use this system, so the online mathy parts in Canvas are done by a system called Myopenmath. And when you click on a place to type an answer, two things will happen, usually. You'll get a little pop-up here that says enter an integer or decimal number, and you can hit more to get a little more information about what kinds of things you can type. And sometimes you get this arrow that gives you other options here. Like infinity means an incredibly large number, and DNE means does not exist. Yeah. And when I clicked here, it says use DNE for does not exist. And if you zoom in right here, that's an 00 for infinity. Super huge, which we're not going to use though. Yeah. I don't think it'll come up in this class. And you should be able to type them with or without zero commas. I like to use commas just to make sure I got it right. And submit. And it says, yeah, you can put the commas in there. And if I check them out, it'll take it too. So I could resubmit. And if you get it right, it'll show you the answer right away. Okay. And sometimes the show answers will have a little more detail. Right. Sometimes it's just the simple number that you enter there. It depends. Yeah. All right, so let's move on. So the next thing that we would look at, and again, the scheme of this class, it's generally prep, workbook lesson, and then homework. Prep, workbook lesson, homework over and over again. It takes us about 2 days to get through one of those, sometimes 3 because it's a little more complicated. The prep will usually have a little information about what we're doing. Earlier I mentioned and it says this at the end of lesson 1, if you read that last page, there are 4 strands to this course. Oops, put up a little bit. So citizenship issues are 1, which is part of the first lesson there. Personal finance stuff is going to come up here and there. Medical literacy stuff is going to come up in this class, and then things about how the physical world works. So those are the main themes of this course that will come across in each lesson. So here it's just, hey, give me an example of what you think a citizenship issue is, a personal finance issue is, health and medical issue, physical world. So they're just kind of warming up to the course some more. And this next section is about place value of numbers, big numbers, small numbers, scientific notation kind of stuff. So this is just, reminding you what the places are, just getting that back in your head, because it's easy to forget if you don't think about it every day. Once in a while, problems will have videos with them or worked examples. And so here the worked example is a video. Sometimes it's actually written out work. Yeah. So it depends on the problem. So you can get extra help if you need to. So anything else fun here? We got some, yeah, words to numbers. So you guys will just fly through this. Rounding, basic operations, conversions. Let's take a look at that right there. Yards and feet. So that's going to come up here, pounds and ounces. And then this is some important reading that you want to do. This is, again, related to the process of this course. If you want to be a successful student, you got a plan ahead. Like, I need to do math. I showed up to class. I need to budget now in the afternoon, maybe a little bit before I go to bed. You got to get your work done. And then it's a good idea to reflect on your work. Like, did I get all my work done? Did I miss anything? Is what I submitted reasonable? Should I double check my submission? Things like that. Take a look at that. All right, conversions, which we're going to see a little of coming up in the course.
Hey, Gary.
Yeah.
I have a couple questions.
Uh-huh.
So when I print off my paperwork,
Yeah.
and I just submit them back to you or scan them?
Yes.
Okay.
Yeah, so once you print it, you can write on it, and then you can take a picture of it or scan it, and you can put that in the submission window.
Okay, thank you.
Yep. So with conversions, we often use conversion ratios. So for example, we had something like on the screen, maybe it was 5 yards, and we wanted to figure out what that is in feet. So to do that, I need to know how many feet in a yard or yards in a feet. And so hopefully we remember, otherwise we look it up. So there are 3 feet in 1 yard. And yeah, and sometimes we can just look at that and say, oh yeah, I got that. So just multiply those two together. But sometimes you have to divide. So if you're ever in doubt as to whether to multiply or divide, any conversion relationship like that can be written as a fraction. I can either write that as 3 feet per 1 yard, or I could write it as 1 yard per 3 feet. Oh, it's a mess up 3. So then what I would do next is I would say, okay, I have 5 yards. Putting a fraction next to it, to get rid of yards, I need the conversion ratio with yards in the bottom, which means I want that first one. So for every 1 yard, there's 3 feet. And so that tells me, oh, I multiply because it's in the numerator. If the number ended up in the denominator, that would be a division. I'll do an example of that in a minute. So in this case, I get 15. And kind of an algebraic idea here, if you have a number in the numerator and a matching number in the denominator, those things, a number divided by itself is 1. They cancel out, leaving only feet for the final unit. Right? So that's one way to do conversion, besides just based on your prior knowledge and experience, you just know that you multiply or you just know that you divide.
Especially if you're going from feet to meter or something.
But yeah, it could be a more complicated thing where there's a bunch of steps in between. Exactly.
That's a college chemistry, and that was all we did.
Hey, Gary.
Yeah. What's up?
Can you leave that up there for a minute?
Yeah. Coming back to it. There we go.
Thank you.
Mm-hmm. That good, Tamara?
I'm almost done.
Okay. Yeah, and again, sometimes I can go a little speedy. If you want to slow me down, just ask.
All right.
Good, Tamara?
I'm on the last line.
Okay.
All done.
Okay. All right, so let's consider another example. Suppose we had a measurement like 8,000 feet. So how far is 8,000 feet in distance or height? Miles might be a better way to state this, right? So then I gotta think about, all right, how many feet are in a mile? 5,280.
Yeah.
So there are 5,280 feet in 1 mile. And so I'm just going to write this as a conversion fraction by just starting with the given number, so 8,000 feet. I want to multiply by a fraction to get rid of feet, so since feet is in the numerator because there is no denominator, then to convert, I put the conversion fraction in feet at the bottom. Miles goes in the top, and then I just put the numbers in the right spot. So 1 mile on the top, 5,280 feet in the bottom. Since the 5,280 is in the bottom, a fraction bar is literally division. So on my calculator, I just type 8,000 divided by 5,280. So if you have a calculator, whip it out, grab my Google calculator. Did I show this the other day that if you type a calculation in a search, you'll get a calculator? So 8,000 divided by 5,280, and Google says, oh, you want a calculator? And Google says it's 1.51515151, and I'm getting the impression those 5 ones might keep going for a while. So we have to round that. So thinking about significant figures, I only had one significant figure in the problem I started with, but somebody might say, well, no, I was confident about the 8 and the hundreds. Maybe somebody claims there's 2 significant figures on that. So I might call it 1.5 miles would be a good estimate here. So I could say this is approximately 1.5 miles. And again, this is 8,000 feet over just a 1. Feet in the numerator cancels with feet in the denominator, leaving me definitely miles. So the other nice thing about the conversion fraction is it helps you confirm you got the right units in the end. And sometimes you might have to do, like if we needed to change this into meters, we might have to convert feet to miles, miles to kilometers, then kilometers to meters, a whole bunch of different steps involved. So the fraction is going to help us keep track of the units. And we'll do some more complicated ones later on. All right, so we get a few more minutes. I'm going to show you what worksheet 2 looks like. Hopes that we get to work on it together tomorrow. How you doing, Tamara? You got that down?
Yeah.
Okay. So back here, after the prep, next we will see worksheet. And I'll take a look at building a spreadsheet later, and I even have a video tutorial about how I put that together there. I will do it live in class tomorrow. So here, speaking of billions and trillions, we have 2 different graphs going on here. So the dotted line is the deficit. Deficit is listed on the numbers on this side. Those are in billions. So for example, 1,000 billion right here would really be a trillion, yeah. On the other side, we have gross public debt. So we talk about all the time in the media, the national deficit versus the national debt. So deficit is what happens each year. the difference between the budgeted amount they want to spend and the budgeted amount they're going to get in. The debt is that accumulation year after year after year. So you'll notice that we have a deficit that's in the 100 billions, but the debt, when you add all up those 100 billions over and over again, you end up with numbers in the 1,000 billions, which is really a trillion. So on this side, we're working in the trillions. On that side, we're working in the 100 billions, just to keep in mind. So the dotted line is our numbers in the 100 billions, this scale over here. The solid line is numbers in the trillions on this side over here, right? So we got to kind of read the fine print to get a handle on that. So again, we have those numbers in words, how many thousands they are in regular notation and then scientific notation. So we'll get used to over time. It'll just kind of be natural that a billion, oh yeah, that's 10 to the 9th, right? 9 zeros. Trillion, oh yeah, 10 to the 12th, it has 12 zeros. A lot of zeros. Yeah, 3 more each time when we go million, billion, trillion. So I'm going to skip on down a little bit here. Suppose we had a stack of 1,000 $1 bills. How tall would that stack be? Okay. Yeah, so here we're told that if you actually measured that stack, you'd find it's 4.3 inches tall. Oh. So 1,000 nice, clean, crisp bills flattened down, getting about 4.3 inches tall. All right, so like the width of my hand, probably maybe a little bit more than that. So imagine getting 1,000 stacks of 1,000. How many would that be? 1,000, 1,000?
I'm just kidding. It's like 100,000. No, a million.
A million, yeah. So if we have, so just make some notes here, 1,000 $1 bills. That's right. Equals 4.3 inches in height. That's it. So now what we want to say is, okay, what would 1,000 be? So that's 1,000 with 3 more zeros. What's that?
Nothing.
Okay. So I've got 1,000 there, which is a million. Okay. So I have a million bills. 0. Now, conversion fraction wise, I really don't need it here. I'm going to throw it in just for fun. I have a ratio of bills per inches. I want to convert from bills to inches, so that means I want to put bills in the bottom and inches in the top. And my conversion ratio says that for every 1,000 bills that you have, you're going to have 4.3 inches in height. So basically, here I have 2 things to do. I have to multiply by the 4.3, and I have to divide by 1,000. Right? And so we can do that pretty much in one shot. So I'm going to whip out my calculator again. Calculator. So I'm just going to clear it. So I'm starting off with a million. 1, 2, 3. 1, 2, 3. And I want to, and the order doesn't matter too much in this case, but I'm going to multiply by 4.3 inches and then divide by 1,000. So I get 4,300 inches. And I could have entered that in one shot in this calculator. If you have an iPhone calculator, it's a little trickier. So starting off with a million, 1, 2, 3, 1, 2, 3, multiply by 4.3, and in the same shot, divide by 1,000. Get the same answer. Yeah. Okay, so 4,300 inches. .4,300 inches. So I got a good feel for 10 inches, 20 inches, 60 inches, but I don't have a good feel for what 4,300 inches is. Do you guys? So what do you want to convert that to?
Feet.
Yeah, let's try feet, see what it looks like. So yeah, so in this case, we would play with, I want to get rid of inches, so that's going to go on the bottom. Feet's going to go on the top, and I know that for every 1 foot, there's 12 inches. So like you said, we're dividing by 12 in this case to make that conversion. So back to my calculator. What's 4,300 divided by 12? Yeah, it's a little messy number, but not too bad. So, how many significant figures do we think we have here? two significant figures if the 4.3 is good. So then here we would probably say it's 360 roughly, okay, depending on how accurate that 4.3 was. So we're assuming it's only accurate with two places. So anytime I round on paper, I put a wavy equal sign instead of a regular equal sign so that when I look at it later or somebody else doesn't say, oh, they rounded it.
Yeah.
So 360 feet about. If that 4.3 is right on, I could probably throw another sig fig on there, but I'm just gonna go with it that way. 360 feet, that's a lot of feet. That's like taller than like a couple of these buildings, right? That's way up there. Okay. So that's 1 million. What if we tried a billion bills?
Oh, no.
Right? So how much bigger is a billion than 1 million? 1,000, yeah, it's 1,000 million, right? So we just, if we want to convert from, where are we now, millions to billions, we're just going to multiply this by 1,000. Yeah, so that's the short way to grab that. So 1 billion $1 bills. So a billion, again, is 1 with 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. Double check. We got our millions over here, and then our billions over there, our thousands over here. Yeah, that seems right. Our conversion is 4.3 inches for every 1,000 bills, which is going to be 1,000 times our last answer, right? So we rounded our last answer to 360 feet, is that right? So if we take that by 1,000, we'll get about the same answer as repeating that calculation. So that would be 360 and 3 more zeros, right? Whoa, 360,000 feet. That's a lot of feet. I mean, I'm having a hard time visualizing 360 feet, never mind 360,000 feet. What do you think we should switch to?
Miles.
Miles, yeah. Do a mile conversion. Based on our previous information, there's 5,280 feet. Feet needs to go in the opposite position because I want to get rid of it. That allows me to convert to miles. All right, back to my calculator. Now, if I went with this 4.3 over 1,000, I'm going to get a slightly different answer, but when I usually convert the sig figs in the end, it'll be pretty darn close. So I'm going to do it 2 different ways to see what happens so we can compare the 2 numbers. So I'm going to clear this out. If I go with my rounded answer, 360 times 1,000, yeah, gives me 360,000. And when I'm on the computer doing this, I can kind of highlight zeros to make sure I get the right number there. Some calculators put commas in, which is really nice. Anybody have a calculator that throws commas in?
Calculator general.
Calculator general, okay. So I want to divide this by 5,280. And I would call it 68 miles. Okay, so I'm going to write that down, and then we'll check the calculation the other way. So this is about, rounded, 68 miles. So what I'm going to do next is, just to double check, I'm going to plug this into the calculator and then use the conversion factor with no rounding in between. I should be in the ballpark, but again, if you round twice in a row, you've increased a little error that wasn't there before. So back to my calculator, clear it out. So we started with 1 with 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's make sure I got that right. 3, 3, 3. I typed that right. And then my conversion factor said to multiply by 4.3 inches per 1,000 bills. Then I want to convert to miles, so I have to divide. Let's see, that's inches. Oh wait, I got to do the feet conversion next. For feet, what did we do? Divided by 12. Okay, so I have to go from inches to feet. So this is where it's getting a little sketchy. I probably should write more down, but it's at the end of class. I'm just going to go with it. So to get to feet, I divide by 12. 12. And then to miles, I have to divide by 5,280.
Okay.
Am I in the ballpark?
You were.
Yeah, 68 if I rounded two significant figures. Yeah, it's the same number either way. So that second way was a wee bit harder. I like the first way where we did one step, wrote the answer, did the next.
You wanted to get real specific.
But if somebody said they needed more significant figures, there is a difference in the two answers. So it just kind of depends. All right. So what have we done? We've mostly finished up section 1. We've started conversions in section 2 and playing with big numbers and scientific notation. Hopefully I'll hear from my boss today as to whether this class is a go or a not go. So give me a call later if you have any question. Otherwise, I'll get in touch with you today. Have a good day. Sign out now. Next class is coming. Yes, Tamara?
I was wondering if there's any way that I can get. They're asking me about getting help over here.
Uh-huh.
And about what the accommodations are.
You mean getting a tutor?
Yeah.
Do they have any you're in Milton Freewater?
I think it's Cindy's. Somebody's called Cindy, or someone like that.
So you're talking about accommodations or tutoring? Tutoring. I can check with the tutoring center to see if they have anybody. Is that what you're asking?
I think. Yeah.
Yeah? Okay. I will look into that and I'll send you an email later today.
All right. Thank you.
All right. You're welcome, Tamara. Have a great day.
You too. Bye.
Okay. See you later, Deidre.
Parker.
Yo.
I'm Kayla.
Oh, they was already done with class anyway. Nobody was in there. Okay. Holy cow. I wrote a lot of crap down. And I'm supposed to get my book at 12:30.